Hello everyone, this is an introduction to AVL trees. What are AVL trees? AVL trees are a binary search tree that balances itself using rotations, and we'll get into rotations in the next video. And the rule for an AVL tree is that all the nodes have to be balanced. And if one node is imbalanced, the whole tree is imbalanced. So how do we calculate the balance factor for each node? We get the height of the left subtree minus the height of the right subtree, and it has to either be -1, 0, or 1. If it's not any of these three, the tree is imbalanced. But there's another way you can do it. If we go through absolute values, if the absolute value of the height of a left subtree minus the height of the right subtree is less than or equal to 1, the tree is balanced. Now, if we do the absolute value of the height of the left subtree minus the height of the right subtree is greater than 1, the tree is imbalanced. All right? Let me repeat myself again. If the height of the left subtree minus the height of the right subtree and the absolute value is less than or equal to 1, the tree is balanced. Now, if the absolute value of the height of the left tree minus the height of the right tree is greater than 1, the tree is imbalanced. All right, and also want to take an important note that every node has to be balanced. If one node is imbalanced, the whole tree is imbalanced. And we count levels, not nodes. All right, we'll get into that, what it means later. All right, so right over here, let me draw out a tree. We're going to get the balance factor of this tree here. And let me just bring the equation from here into here and see if I could just move this. All right, here. All right. And let's go back to a marker. I want to get rid of this. Come on, here and here, okay? So let's get the balance factor for the root node. Let's count the levels for the left subtree. 1, 2. So 2, and the one over here, 1, 2, 2 minus 2. So we could see the tree is balanced. And over here, 1, count the levels. For this, we're going to count for this node over here. So we say this one here, 1 minus 1, this one 0, and this one 1 minus, so this one 0. So right here, this tree over here, you can see, is balanced. Okay? And let's do this tree right over here. Let's get the balance factor for this one. All right, let's count the levels. So we have, when we're counting our nodes, we don't start at the root, the node we're counting the balance factor for, we start below it. So for example, I would start here. 1, 2, 3. 1. You count below. You don't start at the node you're counting at. That you want to get. You don't start at the node you want to get the balance factor for. So this one here is 2, and this tree over here is imbalanced. Alright. And now if I can take these over here, these two, just make them smaller. I can't do that. So we'll just go to another page, and we'll bring this. Actually, we'll bring this to the next page. All right. And let's do one more. All right. Is this balanced? Again, I'm counting the levels, not the nodes. 1, 2, 1, 2. So 2 take away 2, 0. And this one over here, this one node is 0, take away 1. So this one's -1. Yes. This one here, 1 take away 0. So this one's 1. These two nodes are 0. So this tree is balanced. All right, and let's do the final one over here. All right. So let's get the balance factor for the root node. How many? 1, 2, 3, 4, 5. So 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5. And this one's here, 1. So this one's 4. This tree is imbalanced. This tree is imbalanced. So let's do this one here. 1, 2, 3, 4. 4 take away 0. This one's here is 4. 1, 1, 2, 3. This one here is 3. And this one over here is 2. You get the pattern. This one's here is 1. This one's here is 0. And this one's here is 0. As you can see, this tree is imbalanced. Alright, thank you so much for watching this video, and I hope you guys understand the basic concepts of an AVL tree.